Yeah, so the next session coming up is from zero to production, building bulletproof CI/CD pipelines on AWS for software as a service platforms. Yeah, and so it's Rodney's time to take over.
Hello.
Okay. And I'll see your PowerPoint. I think you can switch to slideshow and take it on. Yeah.
All right. I think as Steve has mentioned, my name is Rodney Kipkemoi. I'm from Kenya. I work as a full stack developer / DevOps at Simple Formations. And I'll be taking you towards today's sessions from now from zero to production, building bulletproof CI/CD pipelines on AWS for SaaS platforms. So just a brief overview of what I do. I work, Simple Formation is a compliance automation platform that automates compliance entities across companies, that is to meet government implementations, such as audit trails, performing of annual compliance documentation. So we're automating such processes across company to meet compliance metrics across each of the companies that a particular organization can have. So this is across law firms, company entities, as well as government entities. I'll be taking you through how to deploy an application utilizing Docker, ECS, Fargate, CloudFront CDN, and applying CloudWatch as well as GitHub Actions. So that maybe when you perform a deployment or whereby your team is integrated, we can have multi-stage checks across the code, so that when you're doing deployment, we have validations that errors are not pushed to productions. We also have validations that things are working as expected, as same as cron jobs and all other implementations. So ideally, teams do not fail to write code. They fail at shipping it safely, repeatedly, and at scale. So from what I just earlier described is that maybe you can find that within a production environment or within a working environment across a company, we need to be able to ship features on a single particular piece of code iteratively. That means that we have to be able to provide multi-stage checks across the application, so that we do not push code or unvalidated code or unsupervised code that is approved by the organization to production, causing errors and failures, and also maybe confusing even the clients themselves, because we haven't really performed a feature review of that particular implementation. So ideally, we need to be able to provide steps that is across staging, across development, also across production. Also, we need to be able to have a feedback loop whereby we can get feedback from clients or even from the test teams, so that we can apply the changes needed without breaking any existing code that is working, or also providing rollback implementations when doing so. So we need to be able to, because all these processes can be fragile. So we, as I think one of the panelists said, DevOps is a culture. So within a company, you should be able to adopt a culture of how you guys are shipping or how maybe things are working, so that we don't have confusion of how we're doing hot fixes, how we are pushing new features, or how we're even maybe iterating or rolling back from a particular feature. So ideally, from my presentation, I'll be taking you through now the containerized implementation, that is a Docker, a multi-stage ECS Fargate, and multi-region CloudFront, whereby if we are pushing towards different regions, or we want to be able to have a standby region within the application. For example, if one region across AWS fails, case in point, let's say the way Bahrain failed, I think after the previous clashes with Iran, where they had bombed the AWS Bahrain data center. Then if your services or maybe your application was on that particular region, then you do not have a downtime, and you can just push towards, or maybe your application can be fronted towards a different region if you're provided that. The Fargate pipeline, now this is from development to production, whereby we have the tests. We're going to be creating GitHub Actions to validate that tests are passing across the application, because within a code base, we have automated tests such as unit tests, integration tests. We need to be able to make sure that if particular code is being pushed or a commit is being pushed, that or maybe a PR has been initiated to a development branch, for example, tests can be performed on that particular branch so that things can be able to be merged on that branch without failing. That is particular code builds. If we have errors such as lint errors, as well as just errors within the code, syntax errors within the code, you cannot be able to push code to the development branch, even if, because it's a shared branch across the development team. We do not want to have errors being experienced from different developers as well. The build and scan step, the build and scan step, this ensures that the application is building correctly. And it can also scan for vulnerabilities, because currently with the AI implementation on GitHub, you can scan for vulnerabilities across the application, let's say deprecated packages, and deprecated packages more so. And we can make upgrades, or we can also plan towards upgrading the application at this particular step. And then we can push to staging, whereby now the app is within a staging environment, some such as a UAT, whereby people can test the feature, provide a feedback loop, provide feedback on those particular features, maybe even request fixes on particular features. And with this, we can have a feedback loop whereby if we're from staging, if we don't like what has been pushed, we can go back towards the deployment. And if that is done, or if everything passes on staging, then we can push to production. All this can be achieved through the GitHub Actions. In terms of observability and production ready, CloudWatch provides, now you can be able to configure the infrastructure across your AWS using infrastructure as code such as Terraform, serverless, to configure what you need to observe. Let's say, for example, if you're observing memory across an instance, or maybe storage across an EC2, or even an S3 bucket, or even you're trying to configure how you're going to be getting logs for those particular services themselves. So you can be able to configure that with code, and also be able to let's maybe even create cron jobs on how we're going to be performing such observability procedures. In terms of war stories, maybe I'll just take you through maybe how we doing a rollback deployment from our job. From my job, that is simple formation. We had services running on Bahrain at some point, and then we were able to roll back through CloudFront. We were able to maintain our services live without having edge cases whereby our application is down, and then we need to be able to we need to be able to contact customers or clients that we cannot tell them that Bahrain was bombed. That's not really their concern, because our expectation is that we maintain our application at all points, regardless of what is happening across the world. So that's how you provide CDNs to the particular application, and also be able to route the application and maintain it live at all particular points. For the live demo, I'll just provide a simple implementation of an orders API. So this is just a backend implementation running on an Express server. It's going to be running a Fargate task utilizing Terraform, and it's going to be happening on a Git push. So on Git push, let's say to main or to development, we can be able to set up the simple test steps or the simple gates across which now we will be able to merge code to implementations. So mostly across most SaaS platforms, we have compliance. We have a couple of things that can happen within the application. So we have regulation of data audits, maybe strict change controls, whereby now we need to be able to change implementations across the application. Okay, we also need to have zero tolerance for bad deployments. Let's say if a job does not work, then we should be able to roll back to the safest or maybe the good job that was done, so that the bad job that ran within the backend is not deployed to the application. Also, we should be able to cover high volumes. Let's say if you're experiencing a burst in global traffic across the application, so we should be able to address scalability across the infrastructure that you're using, what type of infrastructure that you're using, maybe the third latency budgets. Some companies or maybe startups, or actually most companies have cloud budget, and sometimes you do not need to exceed that particular budget. So you should be able to provide maybe DevOps infrastructure budget, not a budget, but a timeline. I can't say, is it a timeline? Not a timeline, but a scope. Yeah. Should be able to provide a DevOps scope whereby you're within that particular budget, whereby you can scale correctly across the different services, what service is going to be provisioned, maybe which service is going to be laid out when we have a surge in traffic. Also, if we have, for example, a downtime within a particular region, how is the CDN going to be working? If some of the services that you're working with are not necessarily needed to be live, you cannot have, let's say, for example, a notification service working full time, because maybe it's just needed to be called once in a while, so you can run it as a Lambda also. So how we're going to be provisioning those particular services is also key in how we run the SaaS platforms. Okay, so now what we'll be deploying from my particular implementation, we're going to have the CI/CD pipeline, the GitHub action with the 4 gates. So utilizing the OpenID, this is from AWS configuration. Also environment approvals. I will have the Elastic Container Registry, whereby we'll be provisioning secure, maybe SSH. Now this is a secured tag image, whereby on push it's immutable. That means that for most people, they push images with the latest tag. Now, if you're pushing it with a encrypted tag image, then it can be able to be retrieved, and a user can be, maybe the image cannot be hijacked by different hackers or anybody that is just trying to find vulnerabilities within the system. For compute, we'll be using the ECS Fargate, providing a rollback deployment, and a CPU for just for auto scaling. CloudFront, that is for multi-region provisions with failovers. That is, if a region is down, what's the next action to take on that particular region? Or where are we going to be providing the origin of those provisions? For observability, we have the CloudWatch logs that we're going to be providing. We can also set up an alarming system and showcase it within a dashboard. Also, we can also provision it to other third-party tools. Let's say if you need to provide an observability across your application, if a particular service is down, you can add an implementation whereby it pushes the logs of that particular service to maybe a Jira task, Teams channel, or whatever platform that you're utilizing. Maybe this is just the production architecture that I'll be utilizing. So we're going to have the user, that is now the backend implementation. Let's say if you're calling a particular API call, whereby it's going to be passing the HTTP. We're going to be analyzing the CloudFront CDN, whereby we're accessing the region. So we have a primary region maybe and a secondary region. And we've also provided cache policies to those particular regions. So the HTTP is going to be on the CDN, is going to call the load balancer, whereby it will provision the task, not the task, but now it's provision the service itself towards which region, let's say, yeah, the region that you're going to be going. So if you are hosting our application on maybe US East, and then we have US East as the US East one as the primary region within the application, whereby we have hosted the ECS service. We have also hosted maybe some of the services that we have. Through the implementation, we can have, now we can provision a CDM. If the US East one fails, we can have the secondary service going to the US West, maybe one. And then if that is, the first region fails, then the second region will be the primary. And then the load balancer is going to be pointing towards that particular region itself. So the origin is going to be checked by the CloudFront itself, switching based on the region itself that we're utilizing. Some of the services that I just said I'm going to be utilizing would be the AWS ECR, that is the container registry, the ECS, the CloudWatch, and the roles that are going to be provided by AWS themselves. So that depends on the access that you're being provided to those particular infrastructure, which can be done by an admin, or if you're the admin yourself, you can set yourself using an AWS role identifier. So the multi-stage builds keep runtime image small. So you're going to be using the Alpine base for production depths. Non-root users, provisioning of a health check. We're going to also have a ready check. Let's say if you have an application that you need to configure, let's say you're running a microservice and you need to be able to configure that some of the databases have been connected. Maybe you have an AI agent that needs to be live and you're currently pushing changes. You'll want to have a ready endpoint similar to a health check endpoint to showcase that the database, or maybe these services or these extra third-party implementations are working correctly and that they're already checked. So the events are checked as expected. The SHA tag only, so we're not using the latest. We're just been provisioning the encrypted SHA algorithm. Okay. So with this, we have the complete trade-offs. So we're going to be checking, ideally, when you're doing a deployment, it's essential to identify what service you are doing. So the reason for maybe identifying a problem, not a problem, but identify a solution to your problem. So if you have different services, as I said, we have cost implications across company. We have various services running across a company, and we also need to be able to understand what is going to be served at what particular point. So if we need an on-premise implementation whereby we want our services to be live across the application with no downtime, we can consider different infrastructures such as the EC2s and ECS. So you can run different nodes of the ECS on an EC2. This is usually, I think it's $20 a month for this particular implementation of an EC2, depending on the instance that you're running and also on the region. Some of the regions provision different services, have different services, not services, but infrastructure that are quite expensive compared to the region. So when you're doing a deployment, you can also be able to identify what region, maybe even your clientele is, maybe what region your most of the requests you're going to be getting from. Also, the cost implications of such regions, if also the region that you're hosting your services provides the particular service that you want, because some regions do not really have some services that you want as well. You can also provision lambdas, which are scale and are also available, I think, for 15 minutes. That means if your services are not really active, you just need to be making calls on them, you can have them on a cold start, whereby they just be waiting on how you're going to be calling them. So they can be executable or be live for at least 15 minutes within that particular execution, or when they're being called with the different microservices that you're utilizing. Okay, so for CloudFront across the multi-region implementations, so as I think I explained earlier, whereby we have to establish a failover origin that provides a survival zone for your application. So if, let's say, US East 1 holds the primary infrastructure for your load balancers, or maybe your service, your infrastructure that you have, you can provision a UE West 2 or maybe US West 2 as a failover origin, whereby if the first primary fails, then the secondary will become the primary, and your services cannot really be down based on that particular implementation. So CloudFront also provide zero latency. So if you have different clienteles, because it provides caching mechanism, if you have different clienteles across various regions, and maybe you're experiencing a different surge across one region to the other, because you do not want your application to be bombarded, or maybe the load across the application becomes small because the API calls to those particular regions are maybe far away, and then they have to bounce across different regions so that your clienteles can be served with the product that you're serving. You can provision CloudFront to be able to identify the different checks and balances, whereby if you're experiencing a region surge, we can push the services or maybe point the CDN towards that particular region, and the cache implementation can be simple, or maybe the endpoints, the bouncing points can be simple, and your application can be quite fast compared to if you're hosting it in a different region and you have a surge in traffic. For logs and metrics, ideally, for observability, CloudWatch is usually the most provisioned across the different services and infrastructure on AWS. You can utilize this to identify maybe the logs within your service maybe how your services are working. If you have error logs, or you're trying to identify maybe how the different metrics and insights, maybe the network and the CPU and memory that you have is suffice to the users, or you have maybe you're about to reach a limit towards that particular memory, then you can be able to use CloudWatch, maybe different observability metrics tools to serve your users, or to serve not your users, but to apply changes to the application infrastructure, so that maybe your application can scale correctly, or maybe you can maybe deprovision some of these services if you think they're just utilizing maybe cost implications that are not really necessary for the organization. So that's how maybe you can use the CloudWatch metrics and alarms to provide feedback on how your application is running, maybe what errors are happening within your application, what targeting groups do you need to provide response time, that is in terms of ALB, and also even a notification of how you're going to be provisioning or downtime services itself. So ideally, what does production ready actually mean? Because for a production ready application that is from zero to production, or you can just say from zero to hero, whereby you have your application live, it's being utilized across the platform with different clienteles, whereby you also have observability. We have a feedback loop implementation of how within the CI/CD pipeline, we will have to be observing security, whereby we protect data, identities, and workloads, which are the least privileged. Some of the security metrics that fall into place across this is we have regional security metrics. I think one of them finalists said that we have countries that restrict data to be hosted across different regions. They have to be within the country themselves, which also provides some little bit of complexity within an application or within a SaaS platform. We also have data protection. That means you have to make sure that your application is secure. So within your deployment metrics, you have to ensure that whatever you're deploying, maybe some of the environment secrets, your application APIs that you need to be showcasing, environment variables within the application are secure and properly saved within the application. Reliability, this is designed for failure, whereby now we are providing the different states or the different stages within the application in terms of deployment. The application should not fail at one particular point, and if the fail metrics have not hit, then it cannot proceed to the next stage. Failure is mitigated early before we have the changes, before changes are applied. And also with some of the reliability expectation is that we're also mitigating failures before they happen, such as the multi-region CDN provision. We have the tests that we're providing within the app that we make sure that are passing across each PR, the different staging, and also the feedback loop that we're going to be having when things change, or maybe if we have provisioned a particular app from staging and we need to provide a rollback, then that's how we provide a reliability metrics on that. Observability, that is on the metrics. I think I've talked about that, whereby we observe the logs, the metrics, the traces, so that we can see how the application is working and how we can scale or decouple a couple of infrastructure or services, or maybe even CPU and memory within a particular infrastructure. Automation, ideally, this is the CI/CD pipeline, whereby now we're automating deployment across build, test, and rollback without having to provide a lot of mitigation circumstances, because with each PR we get, we can be able to provide a commit rollback towards maybe the most safest approach. And also, if some of the stages do not work or do not push, then we're not moving forward towards, let's say, the production. We're not moving forward with the failures or maybe the code errors that we are experiencing. Scalability goes hand in hand with production, with the observability, whereby now if we're observing our application and maybe our not application, if we're observing our application and some of the infrastructure are being depleted, or maybe we're experiencing a surge in traffic, then with provisions through infrastructure as code, or maybe even through an AWS console, a developer can be able to provide standby infrastructure, or maybe, it can provide standby infrastructure for them to scale the application across that particular feature or service that you've deployed. So cost implications comes with development or with DevOps, whereby with cost, a company provides different cost metrics for your cloud or for your cloud deployment, and some of the time it means you have to adjust your applications towards these particular costs, and also you have to understand how to optimize spending. That means sometimes duplicating services, sometimes initiating other services, or maybe scaling a different service so that you can meet a particular mitigation or a particular stand. Maintainability involves now clean code documentation, maybe just running by the book of how development or how your code works, ensuring that tests pass within the application, ensuring that builds are working correctly, and that we have proper documentation so that even when someone is doing a deployment or even somebody else comes to continue with the work that you're doing, then they can be able to do it without the 4 gates that I was talking about, whereby we have the tests, the build, scan, the staging, and the production, whereby now we are pushing the code across different PRs. So on every PR, let's say if you're pushing to a main branch or a development branch, we have we've added GitHub Actions to check for the different tests across the application, if they're unit tests, integration tests. We're also checking for builds, let's say if the build passes of the application, because on production, we usually run the build files. Then if you're building, we can build and scan for vulnerabilities within the application, because some vulnerabilities can be included through dependencies imported. So we need to be able to scan the application so that some of the vulnerabilities identified can be mitigated earlier. I think there was a case whereby there was a vulnerability within, was it React? I'm not really sure. There was a vulnerability within React. Was it React or Axios? I'm not really sure about it, but
yes,
yeah.
Also.
It was Next.js, whereby now companies that utilize that particular import on those particular, or that particular dependency experienced a surge, not a surge, but were hacked, and because they were not able to perform best practice across maybe different of these checks, or maybe some of these dependencies that we're importing, they had security vulnerabilities, and which can be exploited by the different hackers across the world. and they were not able to, or maybe the mitigation they did on that particular security check came in after the fact, and that means they were not able to perform some of the checks that is needed. For staging, hereby is whereby we can provide a test environment for different users. If you have a quality assurance team, whereby they need to check. If you also have a test environment, maybe you're pushing your MVP towards a different select group of users, and you need a feedback, or you need feedback to those particular features that you're doing. You can provide the staging environment. Also, the staging environment can be used as across different organizations as the environment whereby developers can integrate all their code base and can identify that most of the implementations, or maybe the integration of the code, works correctly as expected by the organization. Production, that is now when you're moved to the live audience and your clientele is using that. Okay, so the rolling deployments. So at production, replace 2 or 3 tasks, then installed. So this hereby is whereby we're providing rollback towards an application, or maybe a push that was made, and it wasn't really as expected. So we have to provision a wait for service stability. Like I said, within an application, you can push a service, or you can push code towards deployment, and we have to wait for different services because integration happens across different services. If let's say we are integrating a different database for one particular service, and then maybe we have an AI agent across that service, we have to make sure that the agent is live, or some of the security checks or some of the expectations for that particular feature are met. So we should not be able to push that service to production if some of these services are not met, or if there's a delay in some of these services, so that if somebody provides or maybe initiates or works with that particular service itself, let's say it's a payment service, and they are not able to, maybe if it's a payment service connected to a PayPal application and PayPal has not been initiated, then they can say that the PayPal service is not, or the payment service is not working. But initially, it's just that some of the mitigation was not met during the initialization of that particular service. So we should be able to roll back that application so that some of these checks are met, and when we provision that services, or let's say it takes time for the initialization of a particular third-party implementation, cannot be noticed by the application during production. Or we can provide a rollback implementation whereby if something is not met, then we are not able to deploy that service as expected. This can also be done within the pipeline, whereby we're providing a post-health check, or that's across the application. So if it's an API they're running, you can have a post-health check to check that the endpoint is healthy, or maybe the endpoint is ready, or if there's a stalled rollout within now that has failed within the pipeline, then we can also roll back towards that particular session. As I said earlier, I think on March there was a Bahrain bombing by Iran. So the bombing was done on AWS data centers in Bahrain and UAE. So some of the implementations or expectations that can happen, because you cannot expect in a real life situation, you cannot expect a whole data center to go down, but you need to be able to mitigate or mitigate some of the services. So if you're hosting different provisions or different infrastructure for your application across different regions, and then you should be able to mitigate a security check or maybe a downtime across that particular region, and able to, because you don't want your application to be down, And since you depend on that particular region for hosting your services and your servers, you should be able to mitigate it and also provide just a CDN front edge whereby you're provisioning across the different regions, or you are securing your region or your application towards a multi-regional approach in implementation. So if a service goes down, then you should be able to provide a backup service. It's more of a backup or a mitigation strategy in provisioning of services and also scaling of an application towards a particular DevOps approach that ensures that your app is live across the board, regardless of what happens across the region or across the globe. So some of the lessons that was identified across this. So origin groups are not optional for critical paths. So the origin groups, that is the primary origin. So you should not just be basing your application on a primary origin because you do not know what really can happen, or some of the services can be deprecated across that particular region. And you should be able to provision your region or your service towards a multi-regional approach, so that if one service fails, then CloudFront can provide an origin error and then direct your DNS towards the particular region that works. And you can also, with that, you can mitigate some of the circumstances that happen when some of the services go down. Since this also provides a cache mechanism, as I said, if you need to be, you should be able to provide bounce backs towards, if you have a surge in traffic, for example. The CloudFront provides, the CDN provides a caching mechanism whereby you can cache the different data that you have and serve it to the different users at a very fast time, compared to if you have, if you're hosting some of your regions, let's say in the US East or US West, and you have a lot of traffic, maybe in Frankfurt or Germany. It will be better for you to host some of your services, or maybe most of your services, in Frankfurt compared to hosting them in maybe the US West region, because that ensures that your application runs faster, and also recovery time can be easier from this implementation. So maybe let's just go through the code that I was writing, that I had for demonstration. Can you see my implementation?
I'm still seeing the slides.
Okay.
Probably, yeah, we could have a quick walk through the demo and
Yeah, can you see my code now?
yes, we can view your code now.
All right. So on this particular implementation, just a CI/CD demo, whereby we have the different GitHub actions. I'm running a Terraform project, so we have a simple application whereby we're listening on a port 3000. It's just a simple order app whereby we are serving different APIs. We have an health check for the application. We have a ready check. So some of these APIs one can configure to check or provide checks towards, as I said, connections to different third-party expectation. Maybe we also have these are normal APIs whereby you're providing crew operations, maybe to get orders, post orders, maybe get a particular order ID, and also have a 404 error in terms if the route is empty or the page is empty. So for this, we have the CI/CD pipeline, whereby on push towards the different branches. So we can have, for now, I've created a CI/CD pipeline whereby on push to main or to the main branch, or to creating of a PR to the main branch, we're going to be executing some of these services in terms of deployment, and also checking for errors within an implementation. So if we have a multi-stage implementation, we can have an on push to different branches, indicating that we can push, when you push to this, but let's say, for example, if you push to this branch, we have various jobs that are going to be done. So for example, we have a test job whereby we're going to be testing, checking that we're running. So we're going to be running, let's say, the run npm lint, we're testing, if we're checking for lint, we're running the run npm test, maybe you're checking for test implementations. And also you can add different jobs in terms of checks and balances within the application, so that if some of these tests do not pass, or we're experiencing a build error within the implementation, as you can see, we also have the build job. If you're experiencing a build, if it fails, then the code cannot really proceed towards production, because this is a particular pipeline whereby if it works, it moves to the next step. If it works, moves to the next step. So for now, we are checking for any push or creating a PR towards, towards the main branch. We have provisions for AWS, whereby these are the environments whereby we are going to be creating some of the services that we have. So we have the region we've provided. This is the ECR repository. So the container registry that is going to be pushing the code towards the cluster itself. We also have some of the task definitions that you're going to be doing when we're pushing code towards production, and maybe towards staging itself. So I also provisioned a CloudFront distribution ID, whereby if we have a CloudFront implementation, say we have US East 1 down, then as a primary, then the US East 2 will be the secondary. We can provision permissions so that for the content that we have is just on read, you can also have it on write. This particular job has the test job, just a simple test run whereby it tests the packages, not the packages, but the dependencies within the application. It checks for the lint time. It checks for the tests themselves. As you can see, we have different tests. This is just an app test whereby we're checking for the health check. We're checking for if it returns the status that we need in terms of ready. If some of these tests do not pass, because we can have various different tests, considering a SaaS application can have as many routes as the application needs. So we need to be able to provide unit tests for these particular applications, or maybe even integration tests themselves. So from the test, from the CI/CD, we can be able to test those implementations. We can also be able to build the implementation using the build ref. And from this build, we can be able to create an image from the build using Docker, as you can identify, because we have a Docker implementation here, whereby now from the Docker file, we can create a production build. We can create a production build that can be used across now development, staging and development itself, and also check for the health of the application through the index file itself. Okay. So from the CI/CD pipeline, you need to be able to provision now secrets on GitHub, whereby if you are, maybe for most organizations, the secrets are usually provisioned by the DevOps guy, whereby we save. Let me just see if I can share my screen. Are you seeing my browser?
No, we are still seeing your code editor.
What about now?
Yeah, it's visible.
Okay. So from if you are the admin across GitHub, then it means that you can be able to provision secrets or environment variables that can be utilized within your application, so that these are some of the security checks that we can provide at the moment. So at the moment, you can see I provision my AWS ID, maybe my AWS secret, my AWS key, and my AWS secret across this. If we have environment variables across the application, we can also add them here as variables, as variables across the application. Yeah. So you can add them here as variables across the application so that they can be utilized when we push code to GitHub itself. Some of the bullets, not the bullet, but some of the security checks that mostly within a development ecosystem is that developers cannot be able to push code to certain branches. Let's say if the main branch is the production branch, then it means that the production branch has to be protected. So most of the branches that you're working with, a user or maybe a developer cannot be able to push to that branch unless it's from the staging branch itself. So you can have different structures in terms of development. So for a paid service from the previous implementation, whereby we saw that if you have a paid GitHub account, not a paid GitHub account, but a paid GitHub organization, whereby now from the organization you can protect a particular branch and also indicate some of the restrictions that can happen. So maybe on push to main, maybe just development can push to main, other branches can push to development, but main can only receive code from development. We can also restrict any changes that are being made to the main branch or maybe to the development branch, depending on how the organization work or maybe how the development is being performed itself. So once we have created
We lose Rodney. We're having a minor technical network glitch. Rodney, we have lost you a
hello.
bit. Yeah, you're back.
Oh, sorry. Oh yeah, all right. So where was I? So once we have created the build check, the test check, sorry. Yeah, the test check, the build check, we provision now the different secrets and the different variables to the application. And since we are checking on push to main or maybe a creating of a PR to main, now we can provision the different AWS services that we want. So for example, since we are creating a Docker image, the best implementation will be to utilize an ECR container registry, whereby we can build and push the tag to that particular registry. And from that image is where now we can create now the image itself on push to that particular branch. So once we have created the build and the tag, we have the registry here, whereby we take some of these jobs are being provided. You can find some of these code base or templates that are being used across the workflows themselves, depending on what particular infrastructure you're using. on GitHub, as well as you can also use AI for generation of some of these YAML files if you need them, but it's good to understand what they really do or what they are needed in terms of implementation. I think I'm seeing I'm running out of time. I'll just go a little bit faster. You can provide the ECR container registry, create a build for that particular image. From the Docker build itself is where now we can scan for vulnerabilities on that particular build. And if we have vulnerabilities to that build itself, whereby we're going to be checking for vulnerabilities across the different dependencies that you have, maybe you can scan utilizing the different steps. If the status failed, then it means that it failed itself, and we cannot be able to push the code towards that particular container or that particular registry itself. After we've done the security checks, then now we're going to be deploying the application. Once we deploy it, we are deploying now towards a two-step implementation, whereby we have the staging deployment, and also we have the production deployment. So we can do a staging deployment and also do a production deployment depending on how the different checks are happening. So we can say that the development branch, we're pushing towards staging, and if the staging does not work, then it means that if we need a man-in-the-middle implementation, whereby from staging to development, or from staging to production, I mean, whereby we need to initiate a push request or a pull PR towards main, then we can be able to perform that particular implementation. I'll be sharing this particular code implementation on my GitHub. I think it's kind of public at the moment. Okay, let me just go take you through some of the Terraform implementations. In terms of Terraform, you can provide a production and test environment, whereby now you provision the different services. Since Terraform is an infrastructure as code, that means you can provision the different services that you have and that you want to utilize across the application. So we can have different services such as load balancers, the CloudFront, the CloudWatch, maybe an EIC, a container registry, the ECS. You can also provision IAM roles, networks, outputs, security groups across the different services that you're using, that is now providing access or maybe access to the different security load balancers, which ports are going to be available, which target groups are really essential for this. Maybe let's say it's an EC2. What are the target groups of those particular EC2? For the variables, these are just the definitions of some of the implementations that are going to be working within the different environment. So we can have the AWS region, we can have an environment, maybe the app name itself, the container port, which port is going to be open, which port is going to be utilized across the different services. And we also have maybe the image tag of the image itself, whereby, as we say, we're not going to be defaulting to the latest one, but we're going to be using the encrypted implementation to get which one was implemented not earlier, but which build worked correctly. We also have provisioning of CPU, memory, some of the VPCs themselves. With every push towards a particular application, I think they've talked about versioning, whereby we can provide a version towards a particular PR, and then through these versions, whereby we can track what state of the application is, because we can have production state, we can have maybe the staging state, we can also have the state of the application, maybe locally yourself. So we need to be able to identify which version of the application is live, which version is which particular point, and whereby we can also have rollbacks towards these different particular versions, as I said earlier. So through Terraform folder. Here we can provision different envs, whereby we have the environment, and we also have a particular structure of organization. From Terraform provisioning is whereby now we can create a pipeline now from the GitHub Actions in terms of Terraform, whereby we can plan and apply these changes or these requests in terms of infrastructure as requested within the Terraform expectation, whereby now, since you have defined maybe what CloudFront description you're providing, maybe what ECR container you're going to be using, maybe some of the memory, some of the storage that you're going to be using across the different infrastructures within your code implementation or within your DevOps structure or culture, then you can provide the pipeline whereby we can apply, we can plan and apply with also having access to your AWS implementation. Okay. Just for clarity, in terms of Terraform, I'm just going to showcase Terraform. Can you see the image I'm showing?
Yes.
Yeah, so in terms of a Terraform project, maybe some of the best practices that you can identify within your Terraform project. You have to define different environments. So you can have the environments folder, maybe the modules, the policies and the scripts that are going to be initiated within that particular project. So for the environment, as you can see, we have normal file layers across each. So for the environment, you can see we have a dev and production environment. We can have different environments depending on the structure of your organization, whereby let's say we have the dev environment, you can have a test environment, then you can have the production environment, whereby now we have a multi-stage implementation within which code is being pushed. So we have the structures within each folder, I think, showcasing how the different stages are working. So we have the main.tf file, which calls modules with environment configurations. We have the variable.tf file as a showcase, which showcase the resources that are going to be used. And then we have the outputs, which export values. And the Terraform env values, this is usually ignored within the git ignore. And then the backend.tf, which is a remote state config, whereby it just configures the state of your application in terms of which state it is or which particular version it is. So as you can see, we have the dev, the production. In terms of the modules, we have the resource definitions, whereby for the modules, whereby we can provide definitions in terms of networking, compute, database, security, monitoring. That's some of the implementations within DevOps. As you can see, the structure is more or less the same across the files, whereby we have the main, whereby we provide resource definitions, the inputs, the outputs, and then we have a version whereby we can provide a version for each particular module. So if it's networking, we can provide a version for this particular networking. If it's compute, a version for this compute. Database, the version, when we do a deployment implementation, we can do a versioning of every resource that we're utilizing within the application. So for policies, policies here is where now we provide costs or sentinels implementation and also compliance metrics themselves. So for example, if we have different regions and we have a cost implication that we need to indicate, then we can have the policies folder whereby we state what are the cost controls within these particular services that we're utilizing, maybe what are the security outlines, maybe what are the naming conventions that we're utilizing, some of the policies, maybe permissions that we're going to be providing to these particular services themselves. We also have the OPA now this is like now the compliance expectation across the application, because we have different compliance expectations, such as the OFAC. Sometimes we have for payments, we have for code themselves, the ISO policies. We can indicate them here as well. For scripting, for the script implementation, now this just script that you provide in terms of now your Terraform project. So this is where, similar to the GitHub Actions, whereby we have to initiate the script, we plan, and then we apply, and then we can also destroy or also validate some of these services, whereby we're utilizing the changes themselves, or maybe applying the change or provisioning the different services. So if we need to work with deprecating a service, if we need to want to maybe increase a service output or compute power, this where we can run these particular scripts for implementation purposes. Okay. With that, I think I'm going to cut my presentation at that point. I will share the GitHub repository with what I have, and then if you have any question, then you can let me know as of now. Okay.
Yes. Thank you so much, Rodney. It was really truly insightful, sharing real world stories, sharing pointers around production readiness. I think, as an earlier speaker shared, I think so many key takeaways from today's summit. And ladies and gentlemen, thank you for hanging on, and we appreciate. Thank you so much. So at this point in time, I'm going to request Diana to take on the floor. Yeah. But Rodney, we appreciate so much. This is really insightful. I got access to the repo. As you opened it, I was checking it out on the monitor. Yeah, and I could really see principles that probably we need to really encompass in. And hopefully, looking forward to hosting you probably for a meetup. For meetups, we have a longer period. We could even go for 2.5 hours where we can meet up. And yeah, I know we can really have so much insights and gists. And the Bahrain situation with the Iran war was really truly insightful. It gives you food for thought to think through different things of how you do or approach things. Yeah.
Okay.
But thank you so much. Thank you so much for cooking. You've really cooked. I think, yeah, we're in touch, and you are really cooking. We started with a scary screen of Terraform apply failing, yet down the line, it's working. Yeah, thank you so much. Yeah, such a very insightful presentation. We appreciate.
Okay, thank you. Thank you for having me.